Good afternoon, everybody. Welcome to our latest webinar, our Talking Timber webinar. We are covering external applications for timber, and we have some interesting guest speakers to talk to us about that. The webinar is brought to you by Sawmilling South Africa, Stellenbosch University, and the University of Pretoria, and the York Timber Chair of wood structural engineering. And of course, today wouldn't be possible without the support of Rothoblaas South Africa, who are our sponsor today. Rothoblaas is a global company from the Italian Alps and a leading creator of high technology solutions for heavy and mass timber, energy efficiency, net zero, and other better building practice sectors. It has a range of products, including fasteners, connectors, building envelopes, and acoustic solutions, as well as worker safety and tools. In terms of the housekeeping for today, my name is Samantha Choles, firstly, and I'm your host. And in the background, we have Ferdinand Hassan, who will be helping us at the back end. First up is Tim Rypstra. He holds an MSc in chemistry and a PhD in polymer science. His focus is on weathering and protection of wood material and products and service, and he has lectured in wood chemistry, wood degradation, and wood protection, wood anatomy, wood adhesives, and wood quality. He's also been part of the Wood Product Science program at Stellenbosch University and has supervised numerous postgraduate studies in wood science. He has authored and co-authored several specific and popular articles and is a co-inventor of 2 patents related to wood. He is a retired Emeritus Associate Professor in 2014 after 38 years of service, and he's still actively involved in research and education for the timber industry. So we really thank him for joining us, and we'll hand over to Tim, and Ferdinand, you'll share the screen on Tim's behalf.
Thank you very much for the introduction. It's the talk that I'm going to give you is first of all about giving you a couple of weathering examples, and then proceeding to the other section is where we would ask, where does it happen, how does it happen, why does it happen? Then one has to go into certain wood properties that are relevant to weathering, besides some other properties as well, hygroscopicity and anisotropic characteristics. A little bit about the mechanism of weathering, some weathering protection technologies that are used, some tests that can be done, and then ultimately some conclusions. So the topic, or the heading is here, weathering of wood and finished wood, with finished in inverted commas. It can be anything. It can be untreated, uncoated timber or wood, but it could also be pressure treated with preservatives or with waxes or oils, etc. And then also it could be coated with a range of coating products, paints, varnishes, etc., or penetrating finishes. And then also something more recent is then chemically modified wood, how that would weather. Now, first of all, then during exposure to its atmospheric conditions, and this is what is being referred to as weathering, there is degradation of building materials, and it's unavoidable, it's aging. And then generally speaking, one can say that the material and the specific application environment, they determine the rate of weathering and properties of the weathered materials, as you see this in, for example, a brick wall, concrete, fiber cement, roof material, and then wood at the bottom. Then some examples. Next slide, Ferdinand, please. Yeah, some examples. Well, we all over centuries know that wood has been used as a construction material in various applications and industries and products, and the function varies extensively. It can be purely structural, right up to purely aesthetic, and anything in between. And then the question is, under which environments does it happen? And there we have the 3 classes of environments. First of all, the atmospheric conditions, which refer to interior applications and exterior, and that's where the weathering, typically the definition of weathering would include that particular environment, then terrestrial or in ground contact, and then aquatic environments, freshwater or marine water. And the basic question is then, how does finished wood weather? And some of these photos that I'm showing here, they are from South African pine treated with various surface coatings, surface or some other treatments. They've been exposed for at 45 degrees north facing at Stellenbosch. So these are typical weathering phenomena, starting then with a piece of untreated wood, unfinished wood, 1 year more or less under the weather. Deeper checks appear in the hardwood. Further down, if the wax-treated wood, in other words, wood impregnated with waxes, certain droplets are still remaining behind after 10 years. Penetrating finish, after 2 years, it produces an irregular surface texture. And it's not to say that every penetrating finish does that. So these are just specific features of weathered wood. The one on the right-hand side, a piece of wood that, or coated wood, still relatively in good condition, 1 year, and you can see the water repellent surface is still very active with water droplets. Then the next one, film forming coating, the little cracks that appear there, these are as a result of surface checks underneath. In other words, the moisture excluding function of the coating is a little bit, it shouldn't be as it is at this stage. In other words, the protection, the water or moisture penetration protection it should give is not sufficient. Then perhaps something funny, but it happens, hail damage on a film forming coating. Starting off with a little scratch or a circular scratch like that. After 1 year that happened. Next slide, please. Proceeding to a darker accentuated ring, which is then already indicating some fungal growth over there. And a little bit later in another coating, you can see that the elliptical pattern is actually the discoloration in the wood itself. You will notice that the wood grain doesn't show through these coating systems. They have certain pigments that will prohibit that. Then flaking and fungal attack on timber. This is a typical film forming coating that peels away or flakes away as a result of the swelling and the shrinkage that occurred in that particular part of the sample here. Just to refer back to the heading at the top, these are materials that we are looking at. In other words, wood material being coated or treated, showing certain weathering characteristics. Something in this SEM, scanning electron microscope photo, the growth of a mold on top of the surface looks quite rough actually, and normally this would, if you touch it, it would feel very smooth. But this is what can happen depending on the growth conditions for this particular fungus. A crack in a coating with spores or mold growth already happening there, finding its way inside the wood. And then on the right hand side, there's a coating system that is actually, it started flaking, crow's foot cracks developed with this one particularly, and it disintegrated as a coating. Okay, the next slide. Then if we look at certain products, as soon as when you take a material and you put it in a product like a door, a window, or a gate, or a rail like that, then you induce certain weathering characteristics in it. And perhaps it looks bad, but this is what you have to, from this you can understand the mechanism of deterioration of certain products. Of course, insufficiently maintained, a painted hardwood door with at the top there, at the top of the white panel, you see these lines which accentuate the joint. And as soon as when these become visible, then you know there is excessive moisture coming in at that particular point, and also excessive moisture which accumulates at the bottom rail of these fielded panels. Similarly with the window in the center, at the bottom you will find, well, the bottom parts of products, because of gravity, are always suffering more than others. Water running down, accumulating, and especially if there's the possibility of water accumulating at the bottom. That's where at the corners, at the joints, you will find the water seepage through the coating, and then the whole deterioration or weather. Well, it's actually called weathering, but it is part of fungal degradation as well. Something perhaps more recent is an 8-week-old gate that was manufactured or installed, and you will notice at the bottom of the gate, after some rain, these darker marks show that there's more water at the bottom than there is at the top. And then, especially if this material is not treated with a water repellent, in other words, the end grain is not adequately protected, there will be capillary rise or capillary penetration from the bottom, in addition to water maintaining there as a result of the large amounts relative to the top. And then on the right hand side, naturally durable hardwood balustrade, where the warping and pulling at fasteners, spelling mistakes I see there, and the fastener is present. Okay, the next slide, please. Then, not that wood is bad, because that's that might be the impression. This is a timber deck that was installed for 32 years and CCA treated, H4 level, and it's still in a very good, well, relatively good condition. Certain pieces are, of course, have to be replaced, but that's with the variability of the material. That is something that one has to accept. The one in the center, and that's where the other part of that timber deck, also 32 years, one part was replaced partially, and you can see the difference between the weathered and the slightly weathered wooden decking board, which of course gives us information about the weathering mechanism. Then another one on the left-hand corner at the bottom, there's a fascia board, and one needs to specify why. And actually, it's a very good, an excellent piece of study material, although it is not very, you could say, decorative to put that on your roof or keep it like that. But this is a delaminated and deformed TBTO-lindane treated phenol formaldehyde bonded South African pine fascia board. After 30 years, insufficiently maintained, but it shows how delamination occurs as a result of weathering and deformation, with other sections moving out or going out of position. Right on the right hand side, there's CCA cladding, and also the end of rafters that were protected with caps to protect the end grain, because that's where most of the penetration is occurring. Next slide, please. A balustrade or a rail on a bridge, hardwood, naturally durable hardwood. Been there a couple of years. I couldn't actually determine, but I think it's even more than 10 years. But some cracking already occurs on the flat surfaces at the top, and but still, it's still in a very good condition, and it probably the maintenance has to be improved a little bit more. On the right hand side, a naturally durable hardwood deck board, and we all know that contact with a with a wet kind of building material like concrete, and wood being in contact with that, has a higher chance of being attacked by fungus because of the increased moisture content levels. Okay, the next one, please. So where does it occur? And if we have to define it, in other words, what is a suitable exterior condition for that? And this description, which is European one, use class description, it is classified in terms of the moisture content, occasionally more than 20 when it is outside undercover, and some wetting can occur, and then more frequently above 20 than it's outside above ground with weathering and wetting. And then the two other terms, limited and prolonged, which are very subjective terms, are included as well. So When does it happen? Does it take 2 months, 3 months, or does it take longer? So how does it weather? In other words, what is in the environment that is causing weathering of woody material or a wooden product? And there are quite a few of them. Insolation, in other words, the amount of sunshine that is received, and that changes or is subjective to a daily, seasonal, annual variations. In other words, questions such as what is the day length and what kind of UV levels are present. Then in terms of heat, air and wood temperatures that differ. What are the maximum and what are the minimum temperatures? And another important one is the dew point, which will describe when condensation on surfaces can occur. Very important, and this is the most aggressive one, and that is water in either of its 3 states in the gas phase. So here we're typically talking about relative humidities. In liquid phase, anything from rain to dew and other kinds of liquid stages of water. And then in solid as well, that if cracks develop and water is freezing in those cracks, then that freezing action can also cause disruption and stresses in the material. So relative humidity, precipitation type and pattern, frost, fog, hail, and the amount of cloud cover again, which is related to how much water, well, that's a water thing. In other words, it will affect the amount of radiation as well, is important. Wind, what is the drying capacity of wind and the wind speed, the wind direction, driving rain, and the presence of any airborne articles. So as we proceed to this, you see that there are a lot of agents or factors that can be dominant in certain environmental applications or not, particularly say if there's a very heavy pollution level, industrial timber that's being used there can really suffer, and also the presence of sea salt. We all are aware of corrosive properties of metals on the seaside. So there's also, well, all materials are being subjected to somehow to that kind of degradation. Distance from the sea, height above sea level, and then the locality, that the surrounding locality of a wooden product is often influenced by vegetation like trees and bushes and so on, and then buildings, because buildings, they can provide certain shadows for a certain period of time, but the heat, radiation, and the possibility for dew formation is very much affected by buildings or structures around a piece of wood. And then the time aspect, because weathering is a process which requires time. When did it start? How long was it? Was it intense? How frequent was it? And in other words, what are the patterns? And here one thinks typically in terms of rainfall, a long, slow rainfall like we have in Stellenbosch for a week, as opposed to a thunder shower giving you the same amount of water or rainfall, but takes much shorter, has a different pattern or a different impact on the wood material. Okay, next slide. Yeah, looks a bit confusing, but just the background is as follows. These are graphs. The background is as follows: that the two samples, pieces of wood, were subjected to two environments. The one is an open environment, so in other words, it was subjected to all the elements, to sun, to water, and the other one was kept on the roof. And the idea was to find out how the moisture contents and temperatures of these two pieces, how they varied with time. And the selection was made to do that on the clear summer day on the 21st of December. So that's when the maximum insolation was present. Luckily, in that same year, or in 86, there was the same year, on the 20th of December, we also had a rainy day in Stellenbosch. And here you can see that the insolation pattern is quite erratic. Then the opposite, the shortest day of the year in winter, 2nd of June, and we also had a rainy day, typically in Stellenbosch, in the Mediterranean climate we have here. We had a raining day as well. So here you can see that, well, the curves indicate, the red one indicates the temperature variation. So at sunrise, say at 6 o'clock in the clear summer day, 21st of December, that's when the temperature starts picking up and it goes quite high. Actually, it goes higher as the temperature that you will find inside in the timber with the protection, roof protection above it. And that difference we actually refer to as overheating. And it's often possible that when objects are dark in color, that the overheating can be quite severe, even as high as 60 degrees centigrade contact temperature when you touch wood, which is, say, coated with a black type of paint. Then at the same time, when this happens, when the sun is not shining, in other words, in the early mornings, you will find that the temperature is lower. The outside temperature is lower than the inside, or the temperature that is on the roof. And that is what we call undercooling. So with undercooling, you have the same phenomenon as water droplets precipitating on a glass, say a cold beer. And so you will have undercooling leading to precipitation on the material, causing a rise in the moisture content shown in the solid blue line there. Not as smooth, but it's happening because of turbulence and so on. And then as the sun gets out, then you can see that the moisture content of the sample, which is exposed, fully exposed, will now be less than the one that is kept under cover. And so we have undercooling and overheating as two phenomena which are very important. On the right-hand side, the cloudy summer day, the peak, the blue peak that you see there, that's a typical rainfall peak, as one would expect on a cloudy, rainy day. That didn't last very long, and it got to the limit of the equipment measuring the moisture content, and you can see the horizontal line. And then something, well, if we compare that with winter, then we can see that the levels on the left bottom side, the clear winter day, the moisture content levels are quite high during the night or early mornings, and it goes down when the sun comes out. That is a bit of an error in the measurement of the insolation measurement, and then it goes up again. When the sun is set, then it goes up again. And on the right-hand side, the cloudy, rainy day, you can see that it's there. Most of the time, it's far above 40% moisture content. Okay, next slide, please. So doing some statistics on it and just taking out of that the maximum moisture content outside. Okay, that's a printing mistake, is usually higher than the fiber saturation point. In other words, the max 65, 28, 56, 53, that's typically for wood that's being exposed fully during these conditions, even during when it wasn't raining, but it's still quite high above, say, 30%, which is a fiber saturation point. And similarly then with the sheltered condition is that everything is more or less, except for the relatively high 31 for the clear winter day, is 31% and less. In other words, below fiber saturation point. And then one could also say, well, the minimum temperatures of the minimum moisture contents in the rainy day, as one would expect, are higher than when it's a clear day, and the minimums, they are, for the sheltered one, they vary between 6 and less than 20. So with this, more or less, we can more or less get an idea of what levels of change and what levels these moisture contents are changing on a daily basis. And at the bottom, then the MCO range is normally larger than the sheltered range for the moisture content, but also for the temperature. Okay, the next slide, please. So what are the effects of weathering? Discoloration is the first thing that is visible, and it starts with staining because of extractives and fastness spelling mistake again. You can read over it, and it is followed by bleaching and yellowing, depending on what kind of species we are dealing with. It's followed by grain raising, which actually is surface roughening, deformation, which can include bending, warping, twisting, cupping, and that already is generating some forces which are pulling at the fastness. Then a more advanced stage, you can get checking at the surface, and if it really is bad, then you can get splitting at the end grain. So these phenomena are associated with weathering, and then if this carries on, then there's softening, darkening, white spots are formed, and across and along grain cracking, which is typically associated with fungal attack, which sets in when moisture content levels are normally above 20% moisture content. To explain that, there we have to do a little bit of wood science, and it might be boring, but you can just read over it or just be made aware of it. To a chemist, it's quite interesting to look at it, what happens there. So we can have a look at the atomic level, in other words, at how wood is constituted at the atomic level, then how these atoms are combined into molecules which are polymeric or macromolecular, and how these large molecules, because wood is a macromolecular composite, how these are fitted together at a supramolecular and ultrastructural level, and then ultimately we see the cells, and at a much higher level, visible level, we see the tree. Okay, the next slide, please. So at the atomic level, the composition is important. We are dealing with a carbohydrate compound which contains carbon, oxygen, hydrogen, and some other elements as well. These are put together in monomers, which are used to make the polymers, the natural polymers. And the polymers that we have are the monomers are the hexoses. They contain 6 carbons, pentoses 5, which are used up in the polysaccharide polymer, and then phenylpropanes, 9 carbons, are used for lignin. And then there are some others which we don't want to say they are not contributing, but they can really contribute to the characteristics, which ends up, these polymers are then ending up in 40 to 45% cellulose, 20 to 30% polyoses or hemicelluloses in lignin, and they are all bonded together with certain bonds. And actually, we are interested in the number of hydroxyl groups or the water bonding sites which are potentially available for sorption. And in lignin, the one component, there is 1 site. In cellulose, there are 3 per monomeric unit, and there are 3 for the 6-membered and 5, and 2 for the 5-membered units that make up the wood. So the hydroxyl groups are mainly responsible for the hygroscopic characteristics of wood. Okay, next slide, please. And this we can just glance at, please. Here you find the hydroxyl groups in cellulose. This is oxygen, by the way, so you can think what water, which is also a small molecule, where it will fit in. It's still smaller than the hexoses that we have here. It's a linear molecule. It's a homopolymeric, high molecular material, and it has 3 hydroxyl groups per 6 carbons, and it has the ability to form crystals in wood. Going to the other polysaccharides, there are also hydroxyl groups. I only indicated the 2, and the other main component, chemical component, which is in this case a hardwood lignin. It's got 3 hydroxyl groups for every 9 carbon and a 9 carbon rest. Now this is a typical 9 carbon rest with a ring structure with a side chain. And yeah, lignin is 3-dimensional, heteropolymeric. In other words, it has different building units, and the same with the hemicelluloses. They also have different building units. Okay, the next slide. At the supramolecular or ultrastructural model, there we have what we call an N-isotropic arrangement or packaging of polymers into the cell wall. These are just models that illustrate that. Here, for example, at the bottom, in that little block, there are 42 cellulose chains which are all grouped together. And this now is assembled together, taking the next slide, into structures such as a cell wall of the cell wall here with the cell wall layers that differ chemically, differ in their fibril orientation, and also at the connections between the cells, you will find different chemical compositions. And if you're really interested to know how cellulose, hemicellulose, and lignin are distributed in a cell wall, well, this is giving you a picture of that, showing that the primary cell wall is actually quite high in lignin, whereas the secondary cell wall has quite a high amount of cellulose. Okay, next one. And then when everything is put together into cells, we end up with, say, on the right-hand side, with an example or a sketch of a hardwood. The cellular structure is visible, cell walls, we've described that, and each cell in this particular presentation, 3D presentation, has certain functions, and there are certain amounts of these elements in them. And what is important in that is it's an N-isotropic arrangement. In other words, there's no homogeneous pattern that is followed. There's a difference between the radial direction, the tangential direction, and the longitudinal direction in the material. Okay, next one. In the tree itself, when boards are sawn from logs, distinct sections such as sapwood, hardwood, juvenile wood, mature wood, as well as anatomical surfaces are produced. And in the sketch on the left, you see what a tangential surface looks like, a little bit higher up, what a radial surface looks like, and what in the center then what a transverse surface looks like. Reason why this needs to be mentioned is because these are the surfaces that are going to be exposed to weather conditions, and the behavior is different for the different main anatomical directions. In the then we've got something else as well: juvenile wood and mature wood, which is immature wood, and hardwood and sapwood are also entities in the tree that are present. And when we start sawing the tree, then we will see different amounts of these, say, wood components, juvenile wood or hardwood, differ as it is illustrated in this sketch. Okay, the next slide. Not to confuse you further, but hygroscopicity is the main feature leading to the changes that occur during weathering. And in these two sketches on the left, or graphs, we see how the ability for water to be absorbed to wood material is dependent on, first of all, the relative humidity. In other words, where we are when we keep wood under shelter and the relative humidity changes, say, from 30 to 80%. And at the same time, when the temperature changes, how that affects the moisture content of the wood. And in red here, example 1, if it's 80% relative humidity and 25 degrees centigrade, then the moisture content of that piece of wood is 16%. And example 2, which is much drier and a higher temperature, is 5.6. So when wood is going from one condition, say the red one to the blue one, there will be shrinkage occurring. And the magnitude of that difference will actually give us an indication of the weathering potential of that kind of environment in which these changes occur. So this next diagram on the right-hand side shows us how these moisture content and relative humidity change when there's being conditions under those. Okay, next one, please. Together with hygroscopicity or with moisture content changes, there is swelling, which is leading, as you would see on the right-hand side, if you take a cross-section of a tree like that, and you take a perfectly square piece of wood, then depending on where you cut that from the tree, you will find that the dimensional changes that occur with time are different. So this perfectly square one now has this cross-section shape, whereas this one is now more, after drying, this one is less deformed or less shrink in that direction as it is in the tangential direction. Okay, to the right, another slide, please. So the weathering mechanism during discoloration and photodegradation of exposed surface of wood, because that's what typically it starts off, the anisotropic swelling and shrinkage associated with weathering, which are then as a result of continuous changes in moisture and temperature, are together with other associated group properties and environmental conditions responsible for the deformation of wood and then the development of checks and splits. And this opening up of the internal surfaces increases the accessibility to sorption sites deeper into the wood, leading again to high moisture contents, at which more serious damage by fungi. And that's the typical plus 20% moisture content where that it can happen there. So here you can see a swollen, cupped, relatively unweathered piece of wood. Water is standing there, but in this particular case, where it is about 30 years old, water just disappears into it and promoting further degradation. Next slide, please. Weathering protection techniques. The application of surface coatings is one, as you see on the right-hand side with a brush, or pressure impregnation of wood with suitable chemical compounds such as waxes, oils, prepolymers, and they can retard, or somehow a better word is control the uptake of water. And then there's chemical wood modification that to reduce the hygroscopicity of wood, that will help to reduce the amount of dimensional changes that occur. And that will then also make wood last longer. Now, in sorption and rate extent studies, this can be evaluated in the laboratory. Next slide, please. As a piece of equipment that can be used under, say, a dry, warm 45 degrees, 30% moisture content of 5.5. And then when all of a sudden the piece of wood is now subjected from that environment to the other, then the dimensional change of that product can be measured, whether it's a natural piece of wood or whether it's wood that has been treated, chemically modified, or even when it's coated, of course, because the coatings have some sort of retarding effect on the moisture pickup, but also once the moisture is inside, it also has a retarding effect when it leaves the wood. Okay, next slide, please. So treatments to reduce the rate and extent of dimensional response and to reduce checking and splitting are then first of all surface treatment. In other words, you give it a coating. And if this is the blue line, if that is a piece of wood which is now subjected to, say, dimensional change, and it could be wetting conditions or it could be drying conditions, then this surface treatment does not change that extent to which it will go. It will just change the rate that it will happen. Whereas modification of wood, chemical modification, will actually reduce the levels of shrinkage that it can go to. So it's now just a matter of trying to find out what is acceptable for a certain environment. Okay, next slide, please. So performance testing, that's another thing that can be done in addition to laboratory testing, as you saw on the previous slide. Water vapor permeability and liquid water permeability are measurements that can help to find out whether the amount of weathering can be reduced and the effect of that. So that's a typical study which is done on materials, and you can see here that exposure, natural exposure of wooden pieces without any structure, as you will see on the right at the top here, there are window panes which are different to weather than if you are looking at 45-degree or horizontally samples which don't have any processing other than planing and the application of certain coatings or doing certain changes to the structure. So, but to realistically consider the impact of all 4 seasons, a minimum of 12 months exposure is required to generate some useful results. And what you see on the right-hand side there, typically this is not as a result of rain, this is as a result of dew. So atmospheric conditions which are generating dew are quite important, because they are not represented in rainfall figures if one wants to correlate rainfall with the durability or the weatherability of coatings. So when wood or wood-based products in which other components like glue joints and other features are used, then they will also affect the design of the weathering test. Okay, the next slide. So in conclusion, various properties can affect the weathering performance of wood, which is not very helpful and quite a challenge, but we know that species has an effect. The amount of early or late wood, in other words, the growth rate of wood, certain wood with certain growth rates weathers better than others. The presence of sapwood and hardwood. Sapwood is regarded as non-durable, and if moisture content levels remain high in sapwood, then you can get discoloration and later on more serious fungal attack. Juvenile or mature wood, which has a strength implication at least. Reaction wood, which is, all these tests are normally run on normal wood, but in reaction wood your density and permeability is affected. We normally work with knots when we do certain tests, because the introduction of knots, it just makes things more difficult. So, but the size, number and distribution of knots in woody material being exposed has an effect on its weatherability, and then grain deviations, spirality and deformation. So these are typically growth related influences that one tries to eliminate when you are busy with certain testing. And then with wood material, dimensions and shape of wood, a flat piece versus a square cross section, density very important, moisture content, surface quality, whether it's sawn, planed or sanded, the treatment, whether it's been preserved or treated with physical or chemical treatments, sawing pattern, whether it's radial or tangential, orientation and position, and then in the last slide, something in conclusion there. So under H3, above ground conditions, we use wood at MCs, which can be critical, and dimensional changes range in moisture content levels from 0 to 30. Fungal attack will start at levels larger than 20% moisture content. So this is what we have to deal with when wood is exposed above ground. And then with proper design, specs, construction methods and techniques, regular maintenance, that includes repair and replacements, advantage of building with wood should be exploited. For example, wood is relatively easy to work with. It has a favorable mass to volume ratio. Most importantly, it's renewable, has low energy production costs, and it can be disposed of environmentally friendly. And all other materials, construction materials, are subject to degradation, be it weathering. So Everybody is then involved is actually asked to use wood with knowledge and care. Thank you.
Thank you for your expert knowledge and contribution. Now I'm going to hand over to Mariëtte Cooper. So Mariëtte Cooper is the Sales and Marketing Manager for TimberLife South Africa, and she's been with the company since 2004, and her areas of focus at TimberLife include sales, customer relationship management, and product training. So really thank you, Mariëtte, for your time and experts insight, and we look forward to hearing from you. So we'll just pass the microphone over to you. Thank you.
Good day, everyone, and thank you to all the organizers for giving us the opportunity to engage with you and share with you on this platform our knowledge on how to select the best possible outdoor wood finish for your specific timber application using certain guidelines. First of all, today is an informative session. So afterwards, you're more than welcome to ask any sort of questions. I'll try to answer them. And if there's more detailed questions, you're more than welcome to contact us directly. I'll share our company information afterwards, after the session, and then you can email us or contact us on that platform. So if everybody is ready, let us begin. The first question when considering is, or the main factors we need to consider when selecting an outdoor wood finish is, what do we need to use it for? So an outdoor wood finish ideally must protect timber against moisture ingress, UV degradation, biological decay, and also the end result you want to achieve with it. In other words, the final look and feel of your timber application. So let's start off with the first question, and that is, what is the purpose of an outdoor wood finish? So that we would like to summarize in 3 basic functions. First of all, it needs to protect timber against natural weathering by firstly controlling the moisture fluctuations in the wood and also reducing the UV degradation on the wood surface. So controlling moisture fluctuation means that it needs to control the moisture uptake firstly, which occurs when wood is exposed to rain or other forms of free water, and also the subsequent moisture loss when the wood is exposed to dry conditions. Excessive swelling and shrinkage cause movement, and if not controlled, this can cause the timber to check, crack, and also split. When we talk about reducing the UV degradation on the wood surface, that occurs when the timber is typically exposed to sunlight exposure. And also, if not controlled, the UV breakdown and the graying and aging of the timber will occur more or faster than it was originally when it was not sufficiently protected. The second function, in other words, to improve the appearance to protect the timber, and we're talking specifically about untreated non-durable timbers against biological degradation, meaning that it has to protect timber against insecticidal or termite attack, and also protect the timber against wood discoloring fungi and surface mold growth. The third function is it needs to improve the appearance and the natural beauty of the outdoor timbers. In other words, enhancing the wood grain and color, and then also to provide a pleasing decorative finish, giving you the option of having a matte, sheen, or gloss look with or without final color pigments. When looking now and getting back to what is the criteria for selecting an outdoor wood finish, and these can be summarized in the following. First of all, the consideration of what type of timber needs to be finished. In other words, will it be a hardwood or a softwood? That means the difference between a natural dense timber species, for example, your hardwoods like Rhodesian teak, versus your softer, more susceptible timbers like your pine and selecno. Also, the timber that you will be finishing, is it a porous or a non-porous timber? In other words, how readily or not the product will be absorbed into the timber, or the finish will adhere to the timber surface. When talking about the outdoor conditions to which the timber will be exposed, that will mean, will it be exposed in a dry or a more humid climatic conditions? In other words, this will have a direct effect if the timber will tend to have a higher moisture uptake or subsequent moisture loss. Also, will the timber be fully exposed to sun and rain, or will it be protected or partially protected? If you talk about a fully exterior exposed timber versus something like a door, which can be partially protected with a veranda or an overhanging roof. Then also taking into consideration the installation of your timber structure. Will it be a horizontal or a vertical installation? So with that, we talk about, will it be more directly exposed to sunlight and also exterior conditions, or with a vertical application like a balustrade, it will be a little bit more protected and less exposed. Also in consideration, sunlight which causes UV degradation, a north-facing installation versus a south-facing installation. In other words, will the timber be north-facing? That increases the amount of sunlight exposure compared to a south-facing conditions. Then moving on to, in reference to the type of protection, performance, and durability required. The timber needs protection mainly against outdoor weathering conditions. So if we talk about exposed window doors or window frames, or will it need to be protected against mainly mechanical wear? If you talk about a protected, in other words, undercovered wooden deck, but very susceptible to foot trafficking. Or do you need the protected timber in a combination of both, where you've got a fully exposed wooden deck, but also subjected then to full mechanical wear? Also, take into consideration, the timber needs to be protected against biological attack. In the case, like we mentioned before, untreated, non-durable timbers that is susceptible to insecticidal and fungicidal attacks. And then just very quickly, referring to the final aesthetic appearance of the timber, would you prefer the final appearance to have a matte, sheen, or gloss finish? Again, with the option of having wood with or without wood coloring pigments. Also, taking into consideration the ease of application. In other words, can the product be applied by simple brush-on, roll-on, or spray methods, or will it require more technical, complicated techniques? And then with referring to ease of maintenance, will the product be simply applied or reapplication done by simply cleaning the wood surface before recoating? Or does it require labor-intensive, complete stripping of the old coating before reapplication can be done? Okay, then the drying time. Is drying time an issue? Meaning that taking into consideration that quick drying surface coatings are not always the best solution for your specific timber application. And also the cost. Is cost an issue? Bearing in mind what you're basically expecting from your outdoor finish versus the final cost of the product. Okay. Then, considering the question and using our guideline, what types of outdoor wood finishes are available? And very broadly speaking, we've got 3 types of wood finishes available. The first one, and also the more a lot of people know this one, is your traditional film-forming wood finishes or your traditional solvent-based paints and varnishes. These type of finishes tend to give you a high build finish with very poor or little penetration into the wood surface. It will typically have a gloss finish depending on the product itself. It can be a medium to even a high gloss finish and a relatively long lifespan before reapplication will be required. Moving on to the second type, which is your penetrating wood finishes. And these are typically your water-repellent solvent-based wood sealants. These type of products will normally be low build with good to very good penetration into the wood surface. It will provide a natural matte finish, but it will have a relatively short lifespan before reapplication will be necessary. Then the last one is the hybrid wood finishes, where you've got basically the benefit of having the best of both worlds. So you've got a penetrating wood sealer, but it gives you also a bit of a sheen or a building finish on the wood surface. Normally, this will have a medium to a hard build finish, but you will also have the benefit of having good penetration of the product into the wood. It would have typically a sheen to a semi-gloss finish and a medium lifespan before reapplication will be required. Then we refer to what is the suitability and performance of the different outdoor finishes in terms of their behavior, and they do tend to behave quite differently in terms of the suitability of your application, the effective lifespan, the deterioration when exposed outdoors, and the ease of maintenance. For example, when we refer to film-forming varnishes or wood finishes, it's mainly used for vertical applications. So if you can think of your typical wooden doors and window frames, they can last up until 3 years if it's a good quality varnish and up until 5 years for good quality paints. But they will tend to flake and peel once reaching the end of the lifespan. But worth noting that with modern technology and new developments, this is not the case with the new waterborne wood coatings, which are manufactured from modern water-based polymers, and which remains actually flexible and weather through erosion. These type of finishes, the film-forming wood finishes, is however very labor intensive when you need to do maintenance, because it generally means that you have to completely remove the coatings before reapplication of the following coating or the next layer. With continuing on the suitability and the performance, when we talk about our penetrating wood finishes, these type of finishes, we also normally talk in the market about the wood oils. So they are used typically for vertical or horizontal applications, for example, wood cladding and decks, where a more natural finish is required, or a low gloss finish, if I talk about a sealed oil deck. These type of finishes can last between 6 months on decking surfaces, but between 12 and 18 months, for example, on your vertical or covered applications. Also, depending on the exposure, the product weather through erosion. So you'll have no flaking or peeling of the product. And maintenance is fairly easy because you simply need to wipe off the wood surface before application of a maintenance coat. Then talking about the new hybrid wood finishes. These are quite versatile and they can be used for vertical or horizontal applications such as wood cladding, doors, window frames, and also wooden decks. These last quite long. So depending on the exposure again, and very important application methods, and as we mentioned before, it can be applied for horizontal or vertical applications. And then in all circumstances, whether being fully exposed, partially, or fully protected. Again, these type of finishes don't flake and peel. They weather through erosion, and also maintenance is relatively easy. So you only need light brushing or cleaning of the surface before the reapplication of a maintenance coat. Then, if we want to move forward of how can the performance and durability of outdoor wood finishes improve your timber investment? And in our view, it can be improved by adding one of two. Firstly, by adding transparent iron oxides and also UV absorbers or light stabilizers. Transparent iron oxides, when added to wood finishes, will provide added protection on the wood surface where UV degradation takes place by absorbing the harmful rays of the sunlight. And then UV absorbers and light stabilizers are designed and formulated to provide excellent protection, not only to the wood surface, but also to the product itself against UV degradation caused by sunlight exposure. So very briefly, that is my presentation. And just lastly, when we talk about which is the new buzzword, we need to compare the two products being water-based and solvent-based according to their properties. So with reference to the VOC content, water-based varnishes tends to have null to very low content, where your solvent-based finishes are high to very high. With reference to odor, water-based finishes is virtually null, compared to solvent-based finishes, which is normally medium to strong. Flammability, water-based finishes is null, solvent-based finishes high. With reference to drying time, water-based finishes is relatively quick drying, being touch dry on the wood surface within about 30 minutes. And with your solvent-based finishes, it can take up to 24 hours, for example, with high-build varnishes to dry and cure properly to the wood surface. If you talk about the application of the clear product, the wood color changes with water-based finishes will be none. It's completely transparent and clear on the wood surface, where solvent-based finishes, depending on the components, which is normally you've got an oil component to it, will tend to have a slightly yellowing or medium color effect change on the timber itself. If you talk about penetration into the wood surface, water-based finishes have a limited. So in other words, it's more a layer forming on top of the wood surface, where solvent-based finishes, depending on the type of product, being an oil or a varnish, will have good to very good penetration into the wood surface. When we talk about stabilizing the wood structure, the inner structure of the timber, with water-based finishes, it's poor because it's mainly a film forming or sits on top of the timber, and solvent-based finishes are better because it does give you penetration and it actually fills some of the wood cells below the surface. When we talk about water repellency, water-based finishes will have excellent water repellency, and solvent-based finishes, good to very good. Again, the difference between a penetrating matte sealer versus a more like a hybrid finish, which has got a little bit of a surface coating to it. With wear resistance, your water-based finishes are very good to excellent. And solvent-based finishes, good to very good. And then maintenance intervals with water-based finishes, they tend to have a little bit of a longer life before maintenance is required, but your solvent-based finishes will have medium to good. So you'll have need more frequent maintenance codes. For example, on an exposed deck, which has been coated with a natural matte sealer, versus a good, where you've got a good hybrid, let's talk about water repellent finish, a solvent-based one, for example, on a window or a garage door, that will require less frequent maintenance. And then that concludes my presentation. Thank you.
Thank you, Mariëtte. I just want to go back to some questions. There was one for you, Tim. Just trying to find it. Here we go. So it's from Ken Lever, and he's asked, have you carried out extensive testing on indigenous wood? And if so, where would he find information on, I think he meant acacia. So is that something you could advise on? You're on mute, Tim, so just want to unmute yourself there. Are you still on mute, I think? Your top right, you'll find your microphone button.
There we are.
There we go. Okay. Yes, we can hear you.
Can you just repeat the question again, please?
Okay, sure. So it was from Ken Lever, and he asked, have you carried out extensive testing on indigenous woods? And if so, where would he find information on our acacias, mahoganies, teaks for both construction and joinery?
No, not really. More on the commercial species like pine and some eucalyptus. So yeah, no, this is a class in its own when you're working with indigenous wood species, and it's also very much area or region relevant. In other words, using and where you would use them. If you use it for exterior purposes. Or for, say, H2, H3, they will have differences, and there will be differences all around South Africa, depending on your climatic conditions that are there. So I don't know whether that answers the question.
I hope so. That Ken, you can drop a comment in the chat box if it has or hasn't answered your question. And then Ken also asks, with cross-laminated timber panel construction, what are the important moisture and temperature parameters for pine and eucalypt?
During exposure, I presume?
I would imagine so, yes.
Yeah, it's well, normally one would use it with a coated system and also with a proper design, so that there are not you don't have excessive moisture exposure and heat exposure. So yeah, that's well, there are a couple of it's not a straightforward answer, but he's welcome to contact me, then we can find out what is best for that situation, because it's also very much dependent on where you would use it, how you would use it, under what structural conditions, etc. A couple of answers I can give you that.
I'll ask Ferdinand to just pop your email address into the chat box, if that's okay.
Sure, welcome.
Sure, great. And then there's another question here from Anzit Snyders. I hope I pronounced that correctly. And I'm not sure if it's directed to Tim or to Mariëtte, but if using the Chinese scorching technique to seal timber, is it the cellulose that can activate the scorching process that seals the timber? Or can you explain why it doesn't degrade as quickly?
Okay, I'm not familiar with the Chinese method, but I think density would be a first consideration. In other words, if there are differences in density, normally the cellulose contents are the same. So there are yeah, a straightforward answer is not possible. One has to look at what kind of material are we working with, what are the typical density values, and temperatures that are generated in doing that, etc. So, and which are very wood specific. In other words, being a hardwood or a softwood, and density playing a role there as well.
Okay, thank you. And yeah, Anzette, if you once the webinar is finished, I'm sure you could drop an email to both Mariëtte and to Tim if they could answer your questions. And then Ken also asked, and I think this is for Mariëtte, are there any differences between spirit-based and water-based penetrating sealers? I know you did have a table later in your presentation. So I don't know if you want to answer that, Mariëtte.
Okay, if we talk about spirit base, it will be the same, which we refer to as solvent base. So you'll have more penetrating, but it will dry quicker. Typically, you will find it in, for example, wood stains. We'll have a wood stain on the wood surface that dries off very quickly, and versus a water-based sealer or a varnish, which tends to take a little bit longer because it doesn't have a solvent that basically flushes off before drying to the timber, if I can explain it like that.
That, and then what effect will coastal salt air have what effect will coastal salt air have on hybrid sealers or sealants?
We've seen that coastal, it's quite abrasive. You've got, especially with the salt content, but there is products available where you basically need to clean off the surface, remove, if you can call it, the salt bolt on top of the coating that will extend the lifetime of it. But at the end of the day, the coating will still erode away because that's what it's made to do. It's made to basically erode away over a period of time, allowing you to do maintenance, which we highly recommend. I mean, there's no timber structure that you can erect that you can just leave for how many years and just hope that it's going to be okay. So maintenance is very key in upkeeping your sealer and making sure that it does protect the timber effectively.
So we've got a question here from Derek Cock, and he asks, can poplar be regarded as an indigenous timber? I don't know if Tim or Mariëtte can answer that. If not, I'm sure Rothoblaas can help us out with that one. No takers.
Not from our side.
Not from your side. Derek, you know what we'll do is we'll get back to you on that. I personally don't actually know. So we'll double check, and we do have your email address, and we'll drop you an email on that answer.
Just to introduce myself, Mark, I'm area manager of Rotoblaas, South Africa. In terms of timber treatments and protective elements for timber construction, is not really our wheelhouse. We focus on fastenings, air tightness and waterproofing, soundproofing, fall protection, tools and machines. And within these groups of products, we've got some very interesting, I think some very interesting solutions to create durable and structurally sound and long-lasting buildings, along with the types of treatments and coatings that we find in the market. So I'm going to be speaking just very briefly about 4 main topics: ground connections, very briefly on air tightness and waterproofing, something to do with corrosion resistance in screws and steel products, and some very basic termite resistant details that I've seen and we can share. So the first and the most important thing, and one of the most universal problems or challenges when it comes to timber elements, is connecting it to the ground. And we always believe in the law of the 4 Ds in terms of design, and that would include deflecting moisture, drainage, drying, and using durable materials, as well as avoiding interstitial condensation. And this is condensation which happens inside your timber element, whether it's cross-laminated timber or timber frame buildings. So there's just a detail there of where your timber element is raised off your concrete, raised above the ground, and the green and the red that you'll see there, these are waterproofing systems installed to stop a capillary action from the concrete entering the underside of the timber element. Some other ways of looking at elevating or lifting your timber element off concrete in a mass timber or sort of heavy timber frame structure would be a product like AluStart. These are aluminium profiles which can aid in the setting out and connecting your timber element to your concrete. It prevents your capillary action, as I said, and it also level out your CLT panels. Obviously, with CLT and prefabricated timber elements being very, very precise, and concrete sometimes being less so, it's very important to start off on a very accurate substrate to achieve, to achieve a solid construction. Other ways of doing this, these are new products from our side, where you will be using a system called an uplift, which is essentially an angle bracket on a footing. This allows you to basically start your construction on a prefabricated steel bracket and allow you to do your concrete ring beam at the same time as your structure is going up. So it takes away some of the need of accuracy for your concrete work. It also stops or prevents and limits that you don't need to start building after 28 days for your concrete strength. You can do this side by side. So in the picture, the renderings you see here, this is a sort of a heavy timber frame. And on the right-hand side, you'll see they've incorporated, or in this rendering also incorporated, a waterproofing element. In the next slide, you'll see how it could be done with cross-laminated timber, so that your structure can arrive on site and go up even quicker, considering the time of wet works. On a more elementary basis, we could look at doing, we could look at supplying products like post bases. These come with engineered values, so you know exactly what sort of resistance you have from a hold down force. And then they also come in a variety of different materials for different sized timbers, different applications, from stainless steel, galvanized steel, coated steel, etc. Of course, airtightness and waterproofing are very, very obvious and crucial part of protecting timber elements. This is something, like I said, we can really go in depth on. But generally, what you want to achieve with these types of products is sealing of air gaps, sealing of water gaps, and allowing any entrapped moisture within your timber structure to naturally to move out of that wall or roof makeup and naturally ventilate and sort of the atmosphere to balance inside the timber element. Also, something in terms of selecting correct fastener for your timber element, and this really is crucial. According to our studies, what we've seen is there's three main things which affect corrosion in a steel element. And this is your atmospheric condition, so basically where you would find the location of the screw or the location of the steel element, so whether it's in industrial, coastal, inland, rural, etc. Your service class of where your timber will be, so is it going to be inside, outside, sort of exposed, in salt water, etc. And then something else that's become more and more important is the pH level of the timber and how much moisture content is the timber, how much moisture content there is in the timber. Because in fact, the timber can actually attack the screw, meaning that over time, your pH level and water creates a relatively weak acid, which over time will eat away at the screw itself. And why is this important? Well, for the short term, you're going to have a screw connection that looks ugly and will leave black marks on your structure. And long term, you will possibly get a screw failure or a steel connection failure. Something to consider, in the top left-hand corner, you will see we've got in your first line over here, this is your mechanical strength and your corrosion resistance. So with carbon steel screws, your mechanical strength always remains the same. But if you're looking for a higher corrosion resistance, you can apply different coatings to it. And this is in normal carbon steel. That's what your typical screw is made of. In stainless steel, it's a slightly different, well, it's actually completely different. Your more corrosion resistant materials are structurally weaker, and your lower corrosion resistant materials are structurally stronger. So what you'll see is it's a compromise. When one is using stainless steel, you're having a compromise between strength and durability, which with our products that we've developed, we can move away from this compromise and always know that we have a baseline of strength. And then, of course, we have also compared these Evo coatings to stainless steel, where we can see how they perform close to the coast, where we actually find the Evo coating outperforms A2 stainless steel close to the coast, which is basically, it's very uncommon to see that kind of research, but we've managed to discover that this is really, really relevant, and it's very interesting to our markets. And all of this information is available in our smart book for timber screws. Another thing to consider, anecdotally, on decking structures is we found in the market that a lot of times when people are stripping their deck, it's the substructure which is failing and not so much the actual decking. And a very simple way to do that is to put a protective layer on your substructure. And that's what this bottom center picture shows, basically a decking tape to extend the lifespan of your substructure. So just something to keep in mind. Something a little bit closer to home, well, not that close, but very traditional ways of looking at termite resistance. This is a company in Nairobi. On the right-hand side is your shogi bun. That's your Chinese, or I think it's Japanese actually. That's your scorched timber cladding, which protects the timber. And on the left-hand side, you'll see, I beg your pardon, on the left-hand side, you will see a steel detail underneath the CLT structure. This is a termite resisting detail. Essentially, termites can't climb upside down. So a very simple way to solve certainly crawling termites to reach the timber structure. Obviously, this doesn't solve flying termites. Another way of dealing with termites is off-the-shelf products. This would be something like a Termifloor, which you could roll out before your timber structure goes up. Yeah, so that's my bit. Thank you very much.
Thank you so much, Mark, and apologies again. I want to hand over to Tafadzwa Nyanzunda. She was supposed to do our welcoming remarks, but she was stuck in a meeting. And as it happens to be Roy Southey from Sawmilling, South Africa, was unable to make it. So it worked out quite nicely. So Tafadzwa, can I ask you to take the floor? Thank you.
Thank you, Sam. Thank you very much. Good afternoon to everyone. Let me start by thanking you all for staying on the call this long, and also for the participation that and support that we are getting from the built environment stakeholders. So we just want to really appreciate the momentum that this program is gaining, and also I can say the outputs that we've also begun to see in terms of the objectives that as government we pursue in job creation and contribution to growth. It could be very minimal to start measuring now, but I can tell you that we are making progress. So just to sum up on the presentations that have been done today, Prof gave us the scientific background on what happens to wood when it has been exposed to weather or weathering. And then Mariëtte from TimberLife sort of came up with the solutions and also giving a commercial perspective, as well as if we maintain our wood, what happens in terms of look and feel of the timber, as well as extending its life. So I'm sure you found this very useful, and that you're going to also join us in the next webinars. Prof. Dr. Skauk has put in the chat the conference that is upcoming on from the 9th and 10th. On the 9th, we do have a colloquium just focusing on the research that is happening. And then on the 10th, we have a conference. So you are welcome to click on the link and join the conference. When it comes to the next webinars, please keep a look in your emails. You will be getting an invite again to attend the next webinar. So what I intended to do was just to give where we are coming from and what we'll be focusing on this year. I think beginning 2018, 2020, we started this journey. And 2021, through COVID, we've actually seen companies opening and starting to produce cross-laminated timber. We started also the journey of having the Talking Timber webinars, as well as the Wood App was developed. So through 2023-24, we've seen the growth and the strength and the momentum that this Rolling Stone is gathering. So I think without taking much time to say that this year, this is the second, this year it will be the third, I'm looking at the financial year of the webinars that we have done. I think we're still going to have 1 or 2 more webinars to come. We've talking about the conference on the 30th, and then we've also put in the chat the Wood Up workshops that happen at Stellenbosch, as well as they will have another one in Pretoria. So alongside that, we've also had the procurement bill being signed into act, and the climate change bill also being signed into act. So that forms part of the work that we will be doing and working together with academia, industry, as well as government. So this work really is a collaboration. I think most of these links we've already put, and just to say that we have a furniture design competition that you may want to also participate in. It's closing on the 30th of September. We've had the timber design competition that is being run by UP, and it's closing on the 25th. Registration closes on the 25th, and submissions is on the 1st of September, and I think the awards will be announced on the 9th of September. You are also welcome to visit the Wood App. I'm sure Sam will be sharing that. And for those of you that are in manufacturing, just take that, scan that that code where that will take you to our agro-processing support scheme that the dtic is offering to the people that are in manufacturing as well. Whether it's furniture or timber processing, we do have that that incentive that is targeted at you. So once again, I would like to say thank you for joining, and also thank you for supporting the work that we are doing as government, as well as private sector and academia. So this work forms part of the commercial forestry master plan. Yeah, I think with that we can say thank you, and you can go back to your workplaces, and please join us next time. Thanks.
I just want to thank everybody for attending. Apologies that we are a few minutes over time. So yeah, thank you again to Rothoblaas and to Mark for sponsoring this webinar. And on behalf of Sawmilling South Africa, I just want to say thanks again to our speakers and to our sponsors. As always, this is a team effort, and I'm neither a wood expert nor an architect. So I'm really grateful to the expertise from my team, Bram de Villiers of Earthworld Architects, Dr. Skulp Rothoblaas at the University of Pretoria, Prof. Brent Vessels and Dr. Philip Crawford at Stellenbosch University. And I really want to make a special mention to Ferdinand Hassan, who's come on board to help put things together. Really, there is quite a bit of work that happens in the background to get these webinars up and running. So I really appreciate Ferdinand's help here. Yeah, I think you have all commented that it is a very informative webinar, and I really thank Prof. Tim and Mariëtte for your information and your insights. And yeah, I hope the people on this webinar will leave with a little bit extra in their knowledge bank. So without further ado, thank you everybody and goodbye.